So our topic for today is differentiation of inverse trigonometric functions. So we are now on the 18th formula. We have the differential of arc sine u is equals to 1 over the square root of 1 minus u square times du dx. For the differential of arc cosine u is equals to negative 1 over the square root of 1 minus u square plus du dx. And for the differential of arc tan u is equals to 1 over 1 plus u square times du dx. And for the differential of arc tan u is equals to negative 1 over 1 plus u square du dx. And for the differential of arc secant u is equals to 1 over u square root of u square minus 1 du dx. And the other one is the arc sine of cosecant u is equals to negative 1 over u, the square root of u square minus 1 du dx. So, find dy dx if y is equals to the arc sine of 3x. So here we have y equals the arc sine of 3x. So our u here is 3x. Our du dx is 3. And our formula is so as you notice, our dy dx now arc sine, we have 1 over the square root of 1 minus our u square. Our u here is 3x. So we have three x squared. And our du dx is 3. Okay? So, just substitute values. So we have now 3 over the square root of 1 minus 9x squared. So our problem number 2 is find dy dx if y is equals to arc tan of x over 4. So to solve it, we have now y equals the arc tan of x over 4. So here, our u is x over 4. Our du dx is equals to 1/4. And our formula for the arctan is 1 over 1 over 1 plus our u is x over 4. Our du dx is 1/4. So we have now one over 4 times 1 plus x squared over 16. Simplify, we have 1 over 4 times 16 plus x squared over 16. We have now here, we have now 1 over 16 plus x squared over 4, because you can cancel out 4 here. And this now becomes 4. And with that, we have now finally our dy dx is equals to 4 over 16 plus x squared. So for our problem number 3, a ladder is 25 feet long, leans against a vertical wall. If the lower end is pulled away at a rate of 6 feet per second, how fast is the angle between the ladder and the floor changing when the lower end is 7 feet from the wall? So, to illustrate the problem, so we have here the wall. We have a ladder. "25 feet long. So we have an angle here. So, this ladder is being pulled now away at a rate of 6 feet per second. Sa Tagalog, hihilahin. Kasi nakasandal siya. Hihilahin mo ngayon at 6 feet per second. The question is, how fast is the angle between the ladder and the floor. So, the ladder and the floor when the lower end is 7 feet. Kung itong lower end niya ay umabot na ng 7 feet. So as you notice, we can form now a right triangle with a hypotenuse of 25 and the adjacent side is x. So we can use cosine function. So from cosine, we have x over 25. Therefore, our theta now is arc cosine x over 25. How fast is the angle between the ladder floor change with the lower end is 7 feet from the wall? So as you notice, we can take the differential of theta with respect to t when dx dt is equals to 6 feet per second and the x is equals to 7. Applying now the arctan formula for the differential, we have the negative 1 over the square root of 1 minus u squared du dx. Now we can say now that our d theta dt is equals to negative 1 over the square root of 1. Our u is x over 25 square times du dx, which is 1 over 25 dx dt. So substituting now, substitute values, x equals 7 and dx dt equals 6. So our d theta now dt equals negative 1 over the square root of 1 minus x 7 over 25 square times 1 over 25 times 6. So we have now dt d theta dt is equals to negative 1/4 radian per second.